Good morning, everyone. I hope you all enjoyed the keynotes this morning. I really like how in the keynotes this morning they had all this music when the presenters came in. So I wanted that here, but I didn't get it, unfortunately. So thank you all for being here. I'm Muneeb Master, as Perry said. I'm a solutions engineer at Couchbase, and I'm going to be talking to you today about how to get started with an engagement database. And this is part, as you can see, is part of the Couchbase 101 track. So can I just get a quick show of hands of who's new to Couchbase? Okay, good. That's everyone. I just want to make sure nobody's lost, on the wrong track, because this is a beginner session, right? So joking aside, you're probably all wondering, you're here because you want to learn about Couchbase, and you heard in the keynote how important customer experience and engagement is. And you're probably all wondering, what is an engagement database? Well, an engagement database is really just a data platform built on powerful NoSQL technology, enabling you to use the data that you have in an agile, responsive, and scalable way so you can engage with your employees, your customers, and partners through exceptional digital experiences. And so really, it's a Couchbase is a data platform, right? And Aaron covered data platform in the previous session. So I'm not going into the details of data platform, but I'm going to talk about how you start using the Couchbase data platform. Well, the first step is to install the Couchbase data platform, right? And I'm going to show you a few different ways that you can do that, a few different options on how to install Couchbase quickly, right? So I actually have 3 different ways. I call it the quickest way, quicker, and quick, right? So the quickest way to install Couchbase, and this is also on our website as the quickest way to install Couchbase, is to use Docker. And you just have to run one Docker command, right? Docker run. You point it to the Docker image, and it really is the quickest way. And for a lot of people, this is probably a good option because you already have Docker and you're probably already using Docker for other applications on your laptops or your computers. But if you don't, it's very easy to just go get Docker from Docker's website. It's free. Download Docker, install it, right? And run this command, Docker install, Docker run, sorry, and it'll pull down the files automatically from the repository. I'm actually showing a pull of the Couchbase 5.5.0 beta, which is currently available. That, as you must have heard already, is going to be released in the next few weeks. So 5.5.0 beta is available as a Docker image. You can pull that down and install it, and Docker pulls everything down automatically, and then eventually gets everything up and running, and Couchbase is running on your system, right? So I actually redid this morning on my install just to make sure that 5.5.0 beta was working, and I had it up and running within minutes, right? So that's why I call this the quickest install method, right? Now, for those of you who aren't familiar with Docker, or you're afraid of Docker and you're afraid of containers or whatever it is, you want to install a different way. What you can do is install it locally on your machine, right? So I call this the quicker way. It's the next quickest option. It's slightly longer than the Docker option, right? You go to couchbase.com/downloads. You choose your operating system. There's installers for Windows, Mac OS X, various flavors of Linux, such as Ubuntu, Red Hat, Debian, etc. And you just install, right, like you would any other software for your operating system. So pretty simple. The third option is to do a cloud installation. So if you already have a public cloud account, this is another option. And again, this is the third quickest option, so I call it the quick option. Takes a little bit longer than the local installation, of course. You can actually go to Amazon, AWS. You can go to Microsoft Azure, to the marketplace. You can go to the Google Cloud Launcher, and you'll find Couchbase in all 3 of those public clouds, right? So you just do a search for Couchbase, pull it up. We have our CloudFormation templates there. You can deploy an instance of Couchbase, right? Either you deploy a single node, or you can deploy a cluster, right? So those are available if you have the public cloud accounts, and you can certainly use that as an option to do an install. So once you've got Couchbase installed, you just have to perform a few steps to, and I call these quick steps again. I like to say everything's quick when it comes to installing and getting Couchbase up and running. So there's some quick steps you have to perform to initialize the cluster. So what you do is you basically go to the Couchbase web console, which you can access on port 8091 using your web browser. So wherever you installed it, if you installed the Docker, if you did it the Docker way, which was the quickest way, or if you did the local installation, you just go to localhost, port 8091 in your browser, and what you see is you'll see that first screen that does the setup screen, and what you want to do is you choose setup a new cluster, you give the cluster a name, you give the administrator user a password, and you read the terms and conditions. So in 6 easy steps, you go to hostname, port 8091 in your web browser, you choose set up a new cluster, you name the cluster, you set a password for the administrator user. Please read, I bolded read because nobody reads terms and conditions, but you should read the terms and conditions, accept them, and then choose finish with defaults, right? So if you're just doing a quick installation just to get up and running with Couchbase, starting with the default settings is perfectly okay, right? You can always go back and tweak those settings if you need to. So now you got Couchbase installed, and it's set up, and your Couchbase cluster is ready. So where does your data go, right? Where do you start putting your documents, your JSON data, your binary data, whatever it is? Where does it go? Well, in Couchbase, data goes inside a bucket. So Couchbase is a document database, and documents are read from and written to a bucket in Couchbase. And documents in Couchbase can be binary, they can be text, or they can be JSON. But JSON is actually a first-class citizen in Couchbase. So what that means is you can perform additional functions on JSON documents in Couchbase. So like Aaron just talked about like nickel and full-text search. You can perform all of those functions on JSON documents if you store your data as JSON, right? And a bucket could store different types of documents. So that's when you're modeling your data, you think about the types of documents you have, right? So for example, if you're putting in user information, you might have user documents, or you might have documents that are something else about users, like the credit card information or something. Those are credit card documents. So inside a single bucket, you can have those different types of documents, in which case you would think of Couchbase bucket like a relational database, right? Like when we think about when we're comparing relational to NoSQL, we kind of try to make those comparisons, right? When we're doing the paradigm shift. So you might think of it as a database, but you could also store documents of the same type. So you could only have user documents inside a Couchbase bucket if you wanted to. In which case you would think of it as a table. So it's kind of like a logical key space for your documents, right? And this is probably a good time to start thinking about your data modeling and document modeling, because this is where sometimes a lot of people spend a lot of time and effort designing their document model, especially when you're coming from a relational system where you already have some data inside tables and columns and rows and things like that, and you need to, if you need to migrate that data into Couchbase, you need to think about how you're going to migrate that data. And we have some tools available that you can use to import. So one option is, a lot of the existing relational database, the database technologies allow you to export your data as CSV. So you can always export it as a CSV file and then do a quick import using a tool we have called CB import that'll let you import all of the data into Couchbase as JSON. So that's an easy way of getting your data out of a relational database into Couchbase as JSON. Right? Then we also have other integrations, like you can use Talend, which is an ETL tool, to extract, transform, and load your data into Couchbase. And I'm not going to go into that in detail in this session, because there is going to be another session later today that's going to do a deep dive on using Irwin and ETL tools and Talend and things like that to get your data into Couchbase and do the data modeling. So
I'm sorry, which session is that?
It's later today. I think it's in the afternoon, but it's on this track. It's on the 101 track. Yeah, you find it in the agenda. So I'm going to assume in this session that we're starting with a new application and we're building a new application, right? So when you're doing that, when you're building a new application and you're using Couchbase and you want to start writing some applications against Couchbase, you don't have to spend as much time initially on your document model, because your document model will sort of come out of your application model, right? You'll design your objects within your application, and you'll store them you'll just serialize them into JSON and then deserialize them from JSON back into objects, right? So that's the beauty of using a JSON database, a NoSQL database like Couchbase, because it gives you the flexibility of deciding what your data model is going to be based on your application model, right? There is no strict schema that we enforce within Couchbase, so you can easily make changes to it, right? You might start off initially with an object model where you have users and their email addresses and phone numbers and stuff like that inside a single object, but then you might decide, hey, wait a minute, now my application requirements are changing. I have many phone numbers to store or something like that. I might decide to store phone numbers in a separate object called a phone number object or something. You can easily make those changes and serialize and deserialize the data from JSON and back to objects without having to change the schema in Couchbase, right? Because we don't enforce a schema. So in Couchbase, you're just storing JSON. Your application decides what that data model is going to be. So I'm making the assumption here that we're not really coming from an existing system. We're sort of building a new application. So that's why I'm not spending that much time on the data modeling piece of it. But like I said, there is going to be a deeper dive session on data modeling later today. OK? So to create a bucket in Couchbase, you do it using the web console. Very easy. You go to your server, port 8091. And you go to the buckets menu on the left-hand side, and you press add buckets. You give the bucket a name, a memory quota, and then you choose the bucket type, right? When you're choosing the bucket type, it shows you three options: Couchbase bucket, a memcache bucket, a memcached bucket, and ephemeral. A memcached is kind of like a legacy thing. We mostly recommend people not use it anymore, right? So there's no reason to use a memcached bucket. No good reason if you're building a new application to use a memcached bucket. You should be using a Couchbase bucket or an ephemeral bucket. The only difference between a Couchbase bucket and an ephemeral bucket is that an ephemeral bucket is memory only. It doesn't persist to disk. So if you have a caching use case where you don't need your data to be saved to disk, and you want to not have to worry about disk I/O and things like that, or you want to deploy to a server that doesn't have a very fast disk but has a lot of RAM, this is an option where you could use an ephemeral bucket and have a cache-only situation in that case. You still get, with an ephemeral bucket, you still get the full persistence, like you do with a Couchbase bucket. You still get pretty much all the same functions and features. You can still perform nickel on it, full text search, etc. on an ephemeral bucket. It's exactly the same as a Couchbase bucket, except it doesn't have persistence to disk. Most use cases, you'll be using a Couchbase bucket, which persists to disk, and is memory first as well. So Aaron talked about how we are, by nature, a memory first architecture. So everything you do is in memory. So that's why when you're creating a bucket, you do have to specify the quota of the bucket, the memory quota of the bucket, to say this is how much memory you want to allocate to this bucket. And we use physical RAM. We don't do a lot of paging or anything like that. So the data stays in memory. As long as your data set fits, if your data set fits within the memory that you allocate, it'll stay within memory 100% resident, right? So again, in 6 easy steps, how do you create a bucket, right? You go to your browser, port 8091, you go to the web console, you choose buckets in the menu, you press add buckets button, you name the bucket, you choose the bucket type. I say here Couchbase or ephemeral. Don't use memcached anymore, and press add bucket. Pretty simple, right? Another option is if you just want to start playing around with Couchbase, you can start with one of our sample buckets. So within the Couchbase web console, if you go to settings, there is a link there for sample buckets. You can load those buckets. There's 3 sample buckets: the beer sample, the game sim sample, and the travel sample. And so it's very easy to load those. You just click the checkboxes and you hit add the buckets, and they get loaded into Couchbase. And as you can see here, they all have a certain number of items and documents already populated in them. So the beer sample has over 7K. Travel sample has almost 32K documents. And what you'll find is on our website, developer.couchbase.com, you'll find a lot of examples around like the travel sample or the beer sample. So if you want to start playing around with Couchbase, run some nickel queries, maybe start writing some code against the existing samples, it's a good way to get started as well, especially since a lot of our examples are based on these sample buckets. Okay, so now you've got your cluster up and running. You've created your bucket inside Couchbase. You want to start writing your application, right? So like I said before, I'm making the assumption here that you're building a new application, right? You're sort of deciding your data model as you build your application. So how do you connect your application to Couchbase, right? So we have official client SDKs that you can use within your application code. We have official SDKs for the following languages, right? Node.js, Java, C, Go, Python, .NET, and PHP. So you use one of our SDKs to connect to Couchbase. And you can check out our website. There's a lot, like I said, developer.couchbase.com has a lot of information on how to get the SDKs and install them into your development environment, how to get started. There's a lot of good sample code. So for every one of these official SDK languages that we support, you'll find sample code and you'll find examples and things like that. We also have a GitHub repository on GitHub where we have, it's called Dev Guide Examples. If you search for Dev Guide Examples under Couchbase, you'll find plenty of good code samples that you can start looking at to get started with any of these official languages that we support. And with the SDKs, you do get full access to all of the services that we have. So key value, search, analytics, eventing that's new as well now, right? So through the SDKs, you can access all these services, right? And like I said before, if you're storing your data as JSON inside Couchbase, you can run nickel queries and full text search against that data and against the JSON data, and you have access to those through the SDK APIs. So here's an example of a Java, simple Java code just connecting to the cluster that we created earlier, right? We ran the Docker command and we created a cluster. So if you just do a Couchbase, you create a cluster object, Java object, and you say Couchbase cluster.create to get a reference to that object. What this does is it just, because I'm not passing a host name, it's assuming localhost, it's going to connect to the localhost, right? If you do want to, for example, if you did deploy it to AWS or one of the clouds, public clouds I talked about earlier, and you want to connect it, or you installed it to a host somewhere or a VM or something, whatever, right? You want to connect it to that cluster. You can specify, of course, the host names or the IP addresses in that Couchbase cluster.create method. So the way that this works is we call this the bootstrap phase. When our SDK connects to the cluster initially, you don't have to specify during the bootstrap phase. You don't have to provide all of the nodes within your cluster, right? You can specify just one if you want to, right? The way that the Couchbase SDK works is that it'll make a connection to the cluster and do a discovery and determine that then the cluster will respond, the cluster manager will respond and say there's a bunch of other nodes in this cluster and provide that information back to the SDK during the bootstrap process. And then the SDK will then make a persistent connection as part of the bootstrap to all of the nodes in the cluster. So this is really important because that means we automatically discover the nodes in the cluster. So your application code doesn't need to be aware of what the cluster topology is. Your application code can be agnostic to the cluster topology, right? The only good reason to provide more than one node in the bootstrap process is for in case of failure, right? So if 10.0.0.1 is down during the bootstrap, then the API, the SDK will automatically try the next one in the list, which is 10.0.0.2 in this case, right? During the bootstrap process. But like I said, I could have 20 nodes in my cluster and only provide 2 in my create method, and I'll still be connected to all 20 after the bootstrap. That's done automatically by the SDK. And so once you've got the connection to the cluster and you have a reference to that cluster object, the next step is to authenticate. So in 5.0, we introduced roles-based access control. So you can, within Couchbase, within the web console, or through the admin APIs and command lines, you can create the users that have access to the cluster and have access to buckets and things like that. So you can control whether users have read access and write access to buckets and things like that. So it gives you more control on the application side about what the applications can do against the data that's in your bucket. So you do the authentication, and then you get a reference to the bucket object by doing a cluster.openBucket, and you give it the name of the bucket. So in my example, I've got a bucket called users. I do a cluster.openBucket. I now have this reference to the bucket object. And now is where it gets interesting, right? Now is where I can start doing operations against my bucket, right? So I can insert a document. So in this example, this is a bucket operation where I create a JSON object in Java, and it's a user, so I'm giving it a name, Arthur, and email address is kingarthur@couchbase.com, and I'm putting some interests of that user as a JSON array, and then I put the document into Couchbase. So I do a bucket.upsert, which is one of the methods available on the bucket object. An upsert, you might be familiar with upserts from relational databases. It's pretty much the same thing, right? An upsert is if the document already exists, then update it. If the document doesn't exist, then insert it. Rather than do an insert and have that fail and then do an update, right? You can just do upsert in a single action. And once you've upserted a document, you can then go and get that document by the key. So sorry, I just want to go back to the upsert, right? We did create a key for that JSON object when we put it into the bucket, right? So the key is here. So when the create, we provide the unique key that identifies that object. In this case, it's u:"King Arthur. And when you're designing keys, it's totally up to you how you design those keys. In our documentation on developer.couchbase.com, we have some recommendations about using natural keys that you can then go back and look at and sort of understand what those documents are. But the keys can be anything. They can be GUIDs, they can be UIDs, whatever you want them to be, right? In this case, we're using a natural key to say, oh, this is a King Arthur. So that sort of represents that this is a user, and the name of the user is King_Arthur or something like that, right? So we can now go and get that document with the key, because every document inside Couchbase has a unique key. So we do again, against the bucket object, we do a bucket.get and the key of the document, and we get the JSON back. And the assumption here is the system.out.println will call the JSON object.print, and it knows how to print itself, right? Or toString or whatever it is. Okay? So that's an example of how to get a document. Here's an example of how to run a nickel query through the bucket object. So it's, again, like I said before, with the SDKs, you have full access to all of the features of Couchbase. So in this case, we're doing a nickel query. It's a select name from bucket name. Well, I should have put users there, sorry, where the interest equals something, right? And we get the results back. In a relational database, when you run a SQL query, you get a set of tuples back, right? The input to the SQL query is going to be a bunch of tuples, like from rows and columns from different tables. And the output of an SQL query is going to be a set of tuples, rows, and they're going to be rows basically. In Couchbase, the input to the nickel query execution is going to be a set of JSON documents, and the Couchbase server is going to figure out which JSON documents it needs to process, etc., and look at the indexes and so on. And the output of that nickel query is going to be a set of JSON documents, right? So in this case, we're sort of expecting, we know we've only put in one user named King Arthur, and his interest was African swallows, interestingly enough. So we're doing a select from the bucket based on the interest attribute, and we expect to get back King Arthur, right, in this case. You can also do a full text search through the SDK. So this is an example of a full text search where we have already created, the assumption here is we've already created a full text search index inside Couchbase, and you do that through the web console or through the REST APIs, and we assume that index is users unstored, and we're just doing a simple match query here. We're searching for a term, and the term is king, right? So there's different types of match, like different types of queries you can use for full text search, phrase queries, term queries, and things like that. That's all documented in our APIs as well as to how, which types of search queries you can use for full text search. Full text search is not, it's more of an art than it is a science, because you kind of, if you have any experience in search, you know that you kind of constantly tweaking or tuning the search terms that you're using and the search queries you're using and things like that. This is just a simple example of searching by the word king and expecting to get back the result for King Arthur. Yeah, question?
The wildcard search?
Yes, you can. There's even another wildcard. Instead of using a match query, you can use a wildcard matched type of query. So full text search is documented in our documentation, so you can take a look at that as well. In terms of how your application connects to the Couchbase cluster and how it manages the sharding. So in the previous session, Aaron talked about how data is sharded inside a Couchbase cluster. When so in this example, the application is connected to the cluster through the SDK, right? So the assumption is you're using like the Java SDK, for example, or the .NET SDK inside your application. And I talked about how during the bootstrap phase, you don't need to specify all of the nodes inside your cluster, because the SDK will discover the other nodes that are in the cluster and connect to them. So when you do that, what's happening is the SDK has a persistent connection to all of the nodes within the cluster. And when you go and fetch a document, so in our example, if we were to go and fetch the King Arthur document, the SDK will hash the key of that document through a simple CRC32 hashing algorithm, and that'll determine which shard or V bucket, we call it, that document resides on. And that is then looked up inside a cluster map here, and the cluster map says that V bucket or that shard is on this physical node, this physical data service node. And in that way, we're able to go and fetch that document directly from that node. The SDK will go and fetch that document directly from the node. So the cluster map is what allows your application to be agnostic to the actual topology of your cluster, right? Because the cluster map is maintained within our SDK, within our smart client, and we maintain that cluster map automatically. So if that topology of your cluster changes, so if you add 2 nodes to your cluster, you horizontally scale out your cluster, the topology of your cluster has changed, the cluster map gets updated within the SDK. So your application doesn't need to worry about, hey, this document's on this shard, which is on this server. You don't need to care about where the shards are within your application. You just do a get, you just do an upsert, and the SDK takes care of doing that automatically to the right server. And by means of the SDK and being able to know exactly which shard is on which server, we're strongly consistent in that sense. Okay? One other thing I do want to talk about is, so just going back to, I'm just going to go back here. Going back to that cluster map, right? So a basic operation means your applications all, if you have multiple application servers or multiple connections to the cluster from your applications, each of those application servers will have maintain its own cluster map, right, within the SDK. And basically, because the data is distributed evenly, the SDK will know which shard to go to, like I said, to go get the data. If the topology of the cluster changes, if you add nodes, what Couchbase does, it redistributes those shards, like in this drawing, and the cluster map gets updated. This animation shows that. And also, if a node fails, a similar type of thing happens. The cluster map gets updated. So now you've built your application, and you've done all your testing and your development in your lower level environments, and you want to deploy it to production. There's a few things you do need to think about in terms of deployment considerations. So Couchbase, this is a single node of Couchbase, right? So Couchbase has a bunch of services that are part of the node, and every node is the same within a Couchbase cluster. So all of the services are, you could have a data service or a query service or an analytics service, eventing service, etc. You can run all of those services on all of your nodes inside your cluster. So if you were, for example, in a development environment, you may have 13 nodes and all of those nodes running the same service. So in this case, we've distributed the query, the index, the data service, the full text service, the analytics eventing service, evenly across all those nodes within our cluster, right? That's one way of doing it, but with multidimensional scaling, you can do things a little bit differently, especially in a production environment, where you can use multidimensional scaling to distribute those services to independent servers, right? So you can distribute that workload differently based on your application requirements. So, for example, in this drawing, we're showing servers with different, performance characteristics, or some servers may have more CPU or more RAM, where you might want to deploy your global indexes or your query nodes. You may want to, if you're doing a lot of queries inside your application, right? Or you're running, or you have very heavy indexes inside your application, you're doing a lot of nickel. In that case, you may want to deploy the index services to CPU servers that have more CPU, for example, right? So you can offload the work of the query and index to those servers. If you have a lot of data that you want to keep resident in memory, for example, in that case, you would deploy the data service on many servers that have a lot of RAM, because you want to try to store as much of that data in memory. Or if you're doing like an ephemeral bucket where you have a caching use case, you would, again, similar type of thing, you would have several data nodes with a lot of RAM, and then you would deploy the data service to those, because that's where the data resides, right, within the data service nodes. If you're doing a lot of full text search or analytics, you want to offload that work to other servers as well. So just something to take into consideration. Yeah, question? Yeah, so you can do that as well, right? It really depends on your use case, and we have some sizing guidelines on our website, and you can work with us directly to figure out what the right sizing is and what you should take into consideration for your deployments, production deployments, and things like that. Okay. So that about wraps it up. Again, tweet to that hashtag, leave us a Couchbase review, and vote for Couchbase on DBTA. Questions?
Can you have both ephemeral and GSI buckets on the same cluster?
I don't think so, no.
Okay. And when you're creating subdocuments, in order to have your model schema for subdocuments with doc types, so you can have indexes for improved performance, do you have to define the doc type for every nested child document?
No.
Only for the topmost.
Yeah. Mm-hmm.
Suppose in the event I don't have a replica for an index server, and the application runs the index, how does it get the results?
So just to clarify the question, right? So the application doesn't run the index. The index runs on Couchbase, right?
Application get the.
You mean the application calls the query?
Yeah, yeah.
And you don't have a replica of the query? Of the index?
Of the index node, and my index node is down.
If your index node is down and you don't have a replica of the index, you won't have access to all of that data.
That's all. It doesn't go against the data server to get the data.
No, because that part of the index is down.
Okay. All right. Thank you.
Okay. Other questions?
I think everybody wants to get to lunch.
I think they do. All right. Thank you very much, Muneeb.
Thank you, guys.